Hello everyone, in this video we are going to learn about stretching graphs. So when you want to stretch graphs, it's usually multiplied by a constant. So for y equals to fx, you can multiply outside the function. That is y equals to a times fx. It means a stretch of the graph y equals to fx by a scale factor of a in the vertical direction. It means that if you have the point x dot y, after you stretching it, it becomes x a y. Let's look at an example graph. So we have fx, the green line, equals to x squared, and gx, the blue line, is 2x squared, that is 2fx. So you can compare the green and the blue one. When we have the point, the x coordinates at x equals to 1, we can see that the green line is 1 and the blue one is 2 for the y coordinates. So it is stretched by a scale factor of 2 in the vertical direction. Now let us see the orange line, that is half fx. So the orange line, we can see the y coordinate at x equals to 1 is 0.5. So it's stretched by a scale factor of half in the vertical direction. Now we have talked about outside the function. How about the inside the function? Which means the function looks like f bracket ax inside the function, which means a stretch of the graph y equals to fx by a scale factor of 1 over a in the horizontal direction. If there is a point xy in the fx, and after stretching to the f bracket ax, we have 1 over a times x dot y. For example, we have fx equals to x squared, that is green line, so that is a green one, and y equals to f bracket 2x, that is blue one, and y equals to f half x bracket, that is orange one. Firstly, we look at the green and the blue one. We can see if y equals to 1, for the green one, the original one, fx, we have the x-coordinate that is 1. Well, for the blue one, we have the x-coordinate that is half, 0.5. And for the orange one, we have x-coordinate is 2. So we can see the differences between of them. Now we see how the graph is stretched, and we can also learn about the reflection. So for y equals to fx, y equals to minus fx is a reflection of the graph of y equals to fx in the x-axis. For y equals to f minus x in the bracket, it's a reflection of the graph of y equals to fx in the y-axis. We can do an example. So on the same axis, sketch the graphs of y equals to fx, y equals to f bracket minus x, and y equals to minus fx, where fx equals to x times x plus 3. That is a quadratic function. We have the roots of the function that is x and minus 3. So if fx equals to 0, we have x equals to 0 and x equals to minus 3. That means the curve crosses at x-axis at 0 and minus 3. So we can sketch that. The y, x, and here is 0, here is minus 3. And we can see the coefficient of the x squared is positive, so it has a small face. Then the curve looks like that. That is fx. Now for the y equals to f bracket minus x, let me use another color. So the minus x is in the bracket. It's a reflection of the graph of y equals to fx in the y-axis. So we do the reflection as in the y-axis. That is looks like that. That is f minus x. So it crosses 3. Now also it asks you to draw y equals to minus fx. So minus fx means a reflection of the graph of y equals to fx in the x-axis, the purple one. So the reflection x-axis, we have the curve. Like that. So this is this is minus fx. Now let's do some exercise. So there is a point A, 1 minus 2, less on the curve with equation y equals to fx. Part A asks you to state the coordinates that point A is transformed to on the curve with the equation y equals to f3x. We see the constant is in the bracket, which means y equals to f3x is a stretch of fx by a scale factor of thirds in the horizontal direction. So that point A is 1 minus 2, so 1 minus 2, and into f 0x becomes to 1 times the thirds and minus 2 equals to thirds 2. That is a new point of A. Now for part B, so also state the coordinates that the point A is transformed to on the curve with equation y equals to 5fx. So 5 is outside of the bracket, outside the function, which means the curve is a stretch of fx by a scale factor of 5 in the vertical direction. The point 1 minus 2 becomes 1 minus 2 times 5 equals to 1 minus 10. That is a new point. It only changed the y coordinate. For part C, also similarly to the equation y equals to minus fx, it is a so y equals to minus fx is a reflection of fx in the x-axis. That means the point y minus 2, that means for 1 minus 2, the y coordinate has changed. It becomes 1 minus minus 2 equals to 1, 2. That is a new point. And for part D, the question said that similarly transformed and to the equation that is y equals to f minus x. So the minus is in the bracket, which means a reflection of fx in the y-axis. It means that it changed the x coordinate. So y minus 2, the x coordinate has changed. The reflection that is minus 1, minus 2. Here is a conclusion for this lesson. You can pause the video to make some notes. Thank you for watching.